So first, you might have a question in your head like, why is this all relevant? Why are we talking about service in buildings? Why are we talking about FDD? We always point to the studies here, right? Studies from major institutions ultimately show that buildings are not performing as well as they should, right? There's energy drift and energy inefficiency happening in all the existing buildings out there. Comfort complaints are an issue in buildings, an ongoing issue. And the majority of equipment is failing or not living up to its normal lifespan. These studies are out there and they're real. You may ask, okay, so that's interesting, but can an FDD tool really produce results here? Is this software we're talking about today actually effective? And that's again where we can go to, obviously we can go to our real life experience to back that up, but there's also studies out there that prove the case on paper. I would encourage anyone interested to take a look at this Smart Energy Analytics campaign that just looked at the effects on energy efficiency for buildings that were deploying FDD as a tool. The energy efficiency and energy savings potential is there out of the gate when FDD is deployed. Additionally, building energy use just drifts over time. When an FDD tool is deployed, looking at issues constantly, looking for energy opportunities every single day, that drift is kept under control, and actually the amount of savings compounds and grows over time. Studies also show, for getting energy, there's a huge impact just on overall maintenance. So this O&M best practices from PNNL showed that there's a huge impact, 75% reduction in breakdowns on pieces of equipment when FDD is deployed. Additionally, just overall reductions in downtime, reductions in maintenance spend, and more productivity for our maintenance and service people. This is all documented and real. So, okay, FDD can help service. Let's just level set on how service is done to date without FDD. Right now, that primarily falls into two different buckets, right? And it's really depending on the business case and use case of your organization, but you may be in this category on the left, that's run to fail, where not much proactive maintenance at all is taken on a facility, right? You just run equipment until it breaks, and then you call someone when it breaks. The issue with a run to fail approach is not only is it very reactive, there's a lot of emergency situations, but it's also very expensive, right? There's a big labor expense when you're calling people to perform emergency response in your building. There's a big equipment cost when you have to replace an entire pump motor that failed. It would be better to be more proactive and replace the bearings or do more proactive service on it than to have to spend all the money to replace this big part. And there's also kind of maybe even the biggest chunk in what is the collateral cost when a piece of equipment fails. What happens if my production line has to go down for a week because the HVAC system conditioning the space broke and failed? If it's a hospital OR room, what happens if we have to cancel a surgery? There's a lot of collateral impact to cost when equipment fails. So the most commonly deployed way in service contracts to address that is this scheduled preventative maintenance type of service contract. I'm sure a lot of facilities owners or FM teams in the audience are well aware of scheduled PM contracts, right? They center around a checklist of maintenance items. Things that we've determined are really good ways to do proactive maintenance on a piece of equipment. And those site visits by technicians, those checklist rundowns are on a scheduled basis. Typically a technician will come out to site on a monthly basis, a quarterly basis, an annual basis. It's all an agreement between the service provider and the building owner. Where FDD can play in here as a tool for service companies, though, is really to even shift further away from this scheduled PM checklist approach and start introducing a data-driven approach into the service model, ultimately becoming more proactive and by addressing more proactive issues, reducing the ongoing costs out of the typical service contract. So looking at a traditional scheduled PM type of contract, right? This one shows a quarterly visit to a site where a normal checklist is run through. Hey, we're gonna show up every 3 months. We're gonna get on site, look at the BMS alarms, resolve anything that's critical. We're gonna run a checklist items on the chillers, on the boilers. We're gonna replace filters on the air handling units. All these nice typical service items can be performed. What that looks like on paper, right? The preventative maintenance dream. On a Monday, we're taking care of the quarterly maintenance on our chillers. Tuesday and Wednesday are devoted to air handling unit service, so on and so forth. We're going through these checklists on a normal scheduled basis. What this can tend to look like in reality, though, is that a lot of reactive stuff gets in the way. If we're talking about a quarterly type of maintenance, there's 3 months that go on in between service visits without much eyes on the systems and how they're running. So throughout those 3 months, for example, a lot of small issues can pop up, a lot of opportunities for small failures that eventually lead to bigger ones. So if a technician shows up on site for regular chiller maintenance on a Monday, they might be met with a facilities manager coming to them saying, hey, we've actually got this huge issue going on an air handler. This big alarm came on and we're getting comfort complaints. I need to divert you from here, from the chiller PM, and go take care of this issue. By the end of the week, right, as that kind of behavior goes on, sure, we may have addressed all the emergencies that were going on in the building, but what happens to the PM, the service items that we were supposed to be doing? They often get delayed or canceled or pushed out. Just all this reactive type of maintenance gets in the way as a result. So this is where we're going to talk about how FDD comes in. In the term we use for when fault detection and diagnostic incorporates into a service contract is condition-based maintenance. By definition, condition-based maintenance, it's a maintenance strategy, and it monitors the real-time conditions of our assets in the buildings to determine what maintenance needs to be performed. In reality, what this looks like is a shift in an increase in the number of checks we can do and the frequency. So a typical PM scheduled type of service contract will have a number of checks. In this example, hey, we're doing 1,000 checks throughout the building over the course of a year, right? What FDD technology enables is more checks, right? We have all these fancy algorithms going on, looking at more pieces of, all the pieces of data, trying to identify more issues in a facility, but also we're doing this every single day. It's like having a HavTech service professional on your site looking continuously at the BMS, at the control systems, monitoring mechanical systems. So that's the concept. How does it play out in terms of changing service contracts? And what tools like this are doing are allowing us to move a bit away from this traditional scheduled PM type of service contract. One of the ways it's doing that that we'll talk about first is with regard to critical equipment, right? We all know that there's high risk critical pieces of equipment out there. Air handlers that are serving operating rooms or production floors, chillers that are serving data centers. How does FDD play into that? What we say is for critical equipment, there's still a need for humans to go on site and look at this piece of equipment at a regular basis. It's just, this equipment is too important, right? But can we address all this time that occurred in between these monthly visits from a technician? And the answer is yes with FDD. So we're calling this an enhanced PM that the FDD tool really allows. So before the tech goes on site to do a normal PM visit, they're reviewing the FDD tool to look for, hey, what are my top 5 issues in the building? Or if I'm going to service this chiller, what are some of the smaller proactive maintenance items I can pull out of this tool, some of the insights that can really enhance the normal list of PM checks that I do. To go back to the schedule approach that we were looking at, right, that got filled up with all this red, all these alarms. Here's what FDD can do, and it can help in blue here, right? So on a Monday, they're reviewing that FDD tool and finding the issues. That enables action, right? So we can see, hey, we have an air handler here on that the amperage over time is increasing, right? That's a sign that potentially the fan motor is going to fail. So let's get ahead of that type of failure situation. On Tuesday, let's have a technician do some service on that critical air handling unit because we think it's going to fail. We're steering action here towards more proactive service on critical pieces of equipment. And when we get more proactive, what that does in the long term, it eliminates a lot of these emergency failure situations. When the reactivity in the red gets off the board, what gets replaced with it? It's more proactive, more PM type of activities. So for any facilities people out in the audience, what this is doing for your service providers is it's allowing them to give you more impactful service, right? To get ahead of issues before they become too big. And when we think of the costs associated with that, reducing these failure situations saves you a lot of cost. A second approach with critical equipment is a more on-demand type of maintenance. So same thing, talking about critical pieces of equipment, we can use FDD tools to address issues as they come up, right? So instead of having my tech look at the FDD tool before they go on site for that normal visit, they can look at it in between, right? From kind of like a network, an operations center. And when an issue flags that's of a certain severity or over a certain dollar amount, a truck can roll to that site to take care of that issue. Once the issue is completed, then run through the normal list of scheduled PM checks that have to be done there. So a bit more of a intense usage of an FDD tool on critical equipment. And these types of results are real, right? What I'm going to walk you through here is an actual example of a critical air handler and how FDD was used in this type of enhanced approach to catch a small item before it became a large one. What the tool is looking at here in specific and what we've highlighted is that there's some sensors on this critical air handler, this one serving a production floor, that measured the vibration that was coming out of the fan motor, right? The more, basically when there's anomalies, the more fan is vibrating, it's a sign that, hey, something's wrong, probably with the bearings, and that could lead to a failure situation. So here's the case where an FDD tool caught that. It signified, or it signaled that there was a vibration issue on this piece of equipment. We can see here, jumping right into the raw data, that the issue popped up right here. There was a fault at the beginning of the month for a high vibration on the fan. So a technician was immediately sent to the site to grease those bearings and do those, after the bearings were greased, do the regular PMs checks, check out the rest of the unit. It turns out that actually solved the problem, right? The vibration on the fan went down. It went down for a few days, right? But then after about 10 days, hey, the issue started popping up again. We had another fault, right? Same issue. When we see these patterns occurring over time, what this did was say, hey, we think that this motor is about to fail, essentially. there's a recurring issue on the bearings. What this enabled for the facilities, though, was to perform a scheduled shutdown, to coordinate a time that was good for them to bring their service provider up that didn't really impact what was happening on the production floor, and this issue could be addressed in a controlled manner. The alternative here is that without an FDD tool looking at a complex analysis like this, the fan just would have failed, and when it failed, it would have been an emergency and had a lot of impact down the line to the real business case in the production line of the facility. So everything I just talked about as far as service contracts and the use of FDD there was on critical assets, right? Kind of enhancing the regular visits that we're doing. We're going to shift the conversation now to just acknowledge that there's a lot of equipment out there that's less critical to business operations or to human health or to and these types of high volume large assets, so like packaged rooftops, right, are a good example here. Scheduled PM on a packaged rooftop is, let's just say it's traditionally done on a quarterly basis and involves items like, hey, we're gonna change the filters, we're gonna calibrate sensors, we're gonna check out sequence of operations and just walk the unit through its normal operation. What condition-based maintenance allows for is for the analytics tool, the FDD, to actually replace items on the actual checklist, taking a more data-driven approach to the service. So things like filter changes, right? Instead of just going out blindly and replacing filters on a quarterly basis, can we have a differential pressure across sensor across the filter bank to tell us when the filter needs to be replaced? Control service, right? We will calibrate all the airflow sensors once per year. Well, what if that doesn't have to be done, right? We can have the data tell us, the FDD tool tell us when a sensor goes out of calibration, so that we're going out there as needed instead of on a kind of a blind schedule basis. That's the type of condition-based maintenance approach that's available on these high volume, large assets. We're going to look at the same dashboard here, and I'm going to point you towards another real-life example to show this off. And we're going to talk about these filter changes, right? A typical mechanical service. And here's an example of what I described, right? So a condition-based maintenance approach was taken on this particular rooftop unit to identify when the filter needed changing based on differential pressure. So we can see here on the left, hey, the differential pressure got high. A technician was sent out to site to replace the filter. Once the filter was replaced, they then took care of all the other normal PM checks on the unit and walked away, and the data from that filter looked good, right? Normally on the scheduled PM contract, this unit was getting serviced on a quarterly basis. Now having the data to back that up, it turns out that this filter only didn't need to be replaced that often, right? It turns out it was more like 6, 7, 8 months that the filter was good. What that allows for is doing service more on an as-needed approach, and it allows service companies to be more effective and efficient with their time. We want our best technicians taking care of the issues that matter instead of potentially going out and doing all this service on scheduled PM visits that might not actually be needed. So this type of condition-based maintenance approach allows for more efficiency and more productivity out of service contracts. Finally, the last piece we're going to talk about here is another category of low-risk type of equipment, and it's really like smaller equipment, so zone equipment like VAV boxes or exhaust fans, right? I think the reality here is that, you know, a lot of these items are just are not maintained. You know, at least in my experience, we weren't popping ceiling tiles to inspect reheat valves on VAV boxes as part of a service contract on a regular basis. It's just too cumbersome, too much manual effort to look at all this type of zone equipment, right? That's where FDD can come in and actually run digital checks on this equipment. Look at a VAV box all the time in real time and actually point you to issues as they pop up. So instead of getting a hot call from a particular zone, we can identify months earlier that, hey, the valve isn't really operating properly. You should send someone up there to look at it. It really just drives more impact into a service contract, right? More value out of the services that the controls and mechanical companies are able to provide. So condition-based maintenance for all these low-risk zone pieces of equipment, it just enables more service to be done. So that's those are the approaches, the condition-based maintenance type of concepts, the way that service contracts can be enhanced or altogether changed when an FDD tool is introduced. What I'm going to do next is just really just take a few minutes to walk through an actual tool, just to drill home a few points and see how this all looks live in action. So what we're going to look at here is essentially what a service contractor would bring up and look at before they go onto site in order to direct action for their technical team. So what we're looking at here is really powerful, right? So a single tool with a data model underneath it that enables a service provider to look at their entire portfolio of service contracts that are out there, right? A view like this could be drilled down to a single building. It could expand to hundreds of buildings, your entire service portfolio. What it allows for is to start to look at buildings in context, how they're performing against each other. And when that information model piece that I talked about is robust and has all this engineering data, utility costs in it, we're able to calculate, hey, how many dollars are these buildings wasting? How's the indoor air quality in the facility? How is the comfort? We can put scores to that. That's part of the math that goes on in an FDD tool. What that allows from a service provider standpoint is to say, hey, you know, these particular buildings need my attention. I need to communicate this to the facility's owner about you know, what's going wrong in the facilities and the impact that this type of service can have. We're going to go after these worst performing buildings and make sure that the service we're doing there is taking these avoidable costs, that this dollar waste away. We want to address these service items. So the last piece to walk through here is just essentially, you know, the kind of depth of information that a service professional, a service technician can look at here. On the left, what we're looking at is super powerful, right? We're looking at every single piece of equipment that's in a building or in a portfolio and identifying the top 5, the top 10 pieces of equipment that are underperforming. So immediately, right, like we have this scheduled PM type of approach where we have a regular cadence on equipment. I think the conversation shifts when you can see, hey, these 5 pieces of equipment are the worst ones on site. They're underperforming in terms of maintenance, reliability, energy. Let's go look at these. Let's put more time and effort into these underperforming pieces of equipment as we continue to do our regular maintenance checks. It gets even more granular for service teams, and this is where we get into individual diagnostic reports on pieces of equipment, right? And the ability to prioritize. So having a list that shows you, hey, what's the top issue at the top in terms of dollar waste and energy waste in the facility here? we can see, hey, it's a leaking hot water coil, a simultaneous heating and cooling that's happening on this particular air handling unit. So the ability to prioritize and find issues that matter is hugely important. And then finally, for the service folks that are actually going out there and creating the fix, this is the diagnostic report we're talking about. Not only identifying issues like simultaneous heating and cooling, but telling that technician, no need to waste your time figuring out where to go to make the fix. Don't do any manual analysis. We have the data to back that up, that we think it's the heating coil that's stuck open. So go take a look there. If it turns out that's not the case, here's a secondary potential issue. It could be the sensors that we're looking at to make this analysis aren't working or need calibration, right? So the action is there, right? And the data is there to back it up as well. Finally, what this all rolls into is human action, right? The ability to take diagnostic reports and turn them into tasks, into work order items, and then also to report back on that value. So when you ask, hey, what is my service provider doing for me lately, right? Like, how is their contract performing? What are they doing for me? Having the ability to not only count and keep track of the work orders, the activity, but to also be able to say, hey, all of this awesome work we've been doing as part of the service contract over the past year, we've saved you X amount of dollars. Like, here's our value to you. Or we've increased the lifespan of your equipment by so much time, right? Like, we're providing this reportability that shows the value of service contracts.